At 3:18 a.m. on November 7th, 2024, Vincent DeLuca stood in growing room 4 of his mushroom facility near Kennett Square, Pennsylvania, watching the environmental control system display 63 degrees Fahrenheit, while his white button mushroom production required maintaining 58 to 60 degrees Fahrenheit for optimal pinning and preventing premature cap opening that would downgrade product from grocery grade to processing grade. 48 years old, second-generation mushroom grower, operating 4 growing rooms, producing 42,000 pounds. Weekly for Giant Food and Kroger distribution. The facility's HVAC compressor had failed at 11:40 p.m. Backup systems were struggling to maintain 63 degrees Fahrenheit in rooms containing 84,000 pounds of actively fruiting mushrooms worth $126,000 at retail grade prices. And temperature above 62 degrees Fahrenheit for more than 8 hours would trigger cap opening, reducing value to 42 cents per pound processing grade versus $1.50 per pound fresh market. Standard practice said, shut down affected rooms, harvest all mushrooms immediately regardless of size to salvage processing value, and accept $90,720 in lost revenue. DeLuca had harvest crews scheduled for normal 6 a.m. start. A Giant Food distribution deadline requiring 18,000 pounds delivery by noon. And environmental controls failing across rooms holding 3 weeks of production investment. He called his maintenance contractor and his harvest supervisor simultaneously. Someone could restore cooling before cap opening destroyed fresh market quality on 84,000 pounds of product, representing 2 months of revenue. Chester County's Mushroom Belt operates as America's dominant controlled environment mushroom production region, 70-plus facilities within a 50-mile radius, producing 520 million pounds annually, supplying 60% of U.S. fresh mushroom consumption through climate-controlled growing rooms, where temperature, humidity, CO2 levels, and air circulation are managed to decimal precision across 18 to 21-day production cycles. Every day, year-round, workers hand-pick mushrooms at 1.5 to 3-inch cap diameter, moving product from growing room to cooler to packaging facility within 4 to 6 hours for distribution to grocery chains and food service operators demanding shelf life of 7 to 10 days from harvest. This is agriculture divorced from seasons and weather, operating as continuous manufacturing where environmental control failures cost thousands per hour. The labor coordination determines profitability, and product quality degradation occurs in hours rather than days. An industry where capital intensity exceeds $2 million per facility, while profit margins measure 8 to 12% in good years and disappear entirely when temperature or humidity deviations trigger quality downgrades. Vincent DeLuca learned mushroom farming from his father, who established the operation in 1986 when Pennsylvania growers were transitioning from natural cave-based production to purpose-built climate-controlled facilities. His father had operated 2 growing rooms, producing 12,000 pounds weekly, selling to regional distributors at commodity prices averaging 85 cents to $1.05 per pound. DeLuca took over in 2008, expanded to 4 rooms with automated environmental controls, and developed direct supply relationships with Giant Food and Kroger, requiring consistent weekly volumes, specific size grades, and guaranteed shelf-life performance. But controlled environment sophistication created new vulnerabilities. When HVAC systems failed, entire production cycles faced quality collapse that no amount of growing expertise could prevent. The growing facility DeLuca operated cost $1.8 million to construct in 2015. Each room held 14 double-tier beds spanning 60 feet long and 4 feet wide, with composted substrate supporting mushroom mycelium that fruited on 7-day cycles, producing 3 successive flushes before requiring replacement. Environmental controls maintained 58 to 60 degrees Fahrenheit during fruiting, 85 to 90% relative humidity preventing cap dehydration, and 800 to 1,200 parts per million CO. 2 levels optimizing growth rates while preventing excessive stem elongation. The systems worked flawlessly for 9 years. Then they failed during week 2 of a production cycle when 84,000 pounds of mushrooms sat at peak vulnerability between pinning and harvest size. The stage where temperature elevation caused rapid cap expansion, destroying fresh market appearance. The economics were labor-intensive and quality-dependent. At fresh market prices of $1.50 per pound for mushrooms meeting 1.5 to 3-inch diameter specifications with closed veils and firm texture. Weekly production of 42,000 pounds generated $63,000 in gross revenue. Substrate costs ran $8,400 weekly for composted mushroom growing medium. Labor costs consumed $18,900 weekly. 45 workers handpicking mushrooms 6 days weekly at $14 per hour. The climate control costs, including electricity, natural gas, and water, $4,200 weekly. Packaging materials and cooler operation, $3,150 weekly. Distribution and logistics, $2,520 weekly. Total weekly costs, $37,170 against $63,000 revenue. That left $25,830 weekly profit, or $1.34 million annually, before equipment depreciation and facility costs. After fixed costs, actual net income around $385,000. But if temperature failures caused the cap opening downgrading product to processing grade at 42 cents per pound, revenue collapsed to $17,640 weekly. Costs consumed $37,170. And the operation lost $19,530 weekly, or $1.02 million annually. The margin between fresh market premium and processing grade disaster was 3 degrees Fahrenheit maintained continuously across 18 to 21 day cycles. At 4:20 a.m., the maintenance contractor had arrived and diagnosed the compressor failure. Replacement parts wouldn't be available until tomorrow afternoon. Emergency portable cooling could maintain rooms at 61 degrees Fahrenheit. Marginal, but possibly acceptable, if harvest accelerated to remove mature mushrooms before cap opening occurred. DeLuca authorized emergency cooling installation at $8,400 for equipment rental and overtime labor. His daughter Maria arrived at 5:10 a.m. to help coordinate the crisis harvest. 26 years old, holding a food science degree from Penn State. She'd worked the operation for 4 years, while recognizing that mushroom farming had evolved into industrial production management, requiring expertise in HVAC engineering, microbiology, and supply chain logistics that had nothing to do with traditional agriculture. Maria tracked industry data showing Chester County mushroom operations consolidating from 180 facilities in 1995 to 70 in 2024, with average production increasing from 2.8 million to 7.4 million pounds annually. Mid-sized growers were disappearing as retail buyer volume requirements and environmental infrastructure costs created barriers favoring either large operations with redundant systems or complete exit from mushroom production. "Dad, we're calling emergency harvest at 5 a.m. because temperature control failed. The mushrooms are perfect. We grew them correctly. But infrastructure failure destroys everything." That's mushroom farming now. Growing the product is maybe 30% of the business. Climate control, labor coordination, and distribution logistics are 70%. Then we're industrial manufacturers, not farmers. And when manufacturing infrastructure fails, everything fails regardless of biological expertise. DeLuca understood. Mushroom production had transformed from agricultural craft into controlled environment manufacturing, where technical systems mattered more than growing knowledge, and capital requirements for redundant infrastructure exceeded what family operations could sustain profitably. By 6:40 a.m., harvest crews had picked 28,000 pounds from the affected rooms. Room temperature had stabilized at 60.8 degrees Fahrenheit with emergency cooling. Acceptable, but requiring continued monitoring. Quality inspection showed 88% of harvested mushrooms meeting fresh market specifications with proper cap closure and firmness. The remaining 12% showed early veil breaking requiring processing grade classification. Sir, total crisis impact. 10,080 pounds downgraded to processing at 42 cents per pound versus $1.50 fresh market meant revenue loss of $10,886. Combined with $8,400 emergency cooling costs, the temperature failure consumed $19,286 from weekly profit of $25,830, eliminating 75% of the week's earnings. Vincent DeLuca continued mushroom farming through 2026, managing environmental systems, coordinating labor crews, and watching margins compress as electricity costs increased 28%, while retail buyer prices remained flat at $1.50 per pound. In spring 2027, Giant Food announced new sourcing requirements. Mushroom suppliers must deliver minimum 75,000 pounds weekly beginning in 2028, a 79% increase over DeLuca's current 42,000-pound production. Meeting the requirement meant expanding from 4 to 7 growing rooms and investing $1.4 million in additional infrastructure with redundant environmental controls. He met with Maria in April 2027 to discuss expansion. The analysis was prohibitive. $1.4 million infrastructure investment against current net income of $385,000 annually meant 4+ year payback periods, assuming perfect operations with zero equipment failures. Maria had no interest in inheriting debt-financed expansion into an industry where retail buyer consolidation was systematically eliminating mid-sized producers through volume requirements that served buyer logistics efficiency while destroying grower economics. Maria, we either scale to meet Giant's minimum or we lose our largest customer and compete for spot market sales at $1.10 per pound instead of $1.50. Dead. And scaling up increases dependency on buyers who change terms unilaterally. Spot market means competing with operations running 15 million pounds annually, who can undercut us on cost. Neither works at our scale. Vincent DeLuca sold his mushroom operation to a regional producer, managing 18 million pounds annually across 3 facilities in fall 2027. The sale, $2.8 million for infrastructure and customer contracts, allowed him to retire at 51 with sufficient equity. Maria took a position with Giant Food as a fresh produce quality manager, using her Penn State food science education and family mushroom knowledge to specify standards for the suppliers who had replaced her family's operation. Chester County's 70 facilities continue producing 520 million pounds of mushrooms annually in climate-controlled environments, maintaining 58 to 60 degrees Fahrenheit and 85 to 90% humidity year-round, supplying 60% of U.S. fresh consumption through daily harvest and 4 to 6 hour processing timelines. The environmental controls operate regardless of facility ownership. The hand-picking continues regardless of which families develop the production systems. The distribution networks function regardless of who meets the delivery schedules. The system persists through precision that family operations created but can no longer operate profitably at scales too small for infrastructure redundancy and volume commitments buyers now require. If this story moved you, please like and subscribe. Your support helps us preserve these histories of American agriculture's transformation. Tell us in the comments where you're watching from and whether you understand the controlled environment pressures crushing specialty growers. Thank you for keeping their stories alive.